Now let us look at static versus dynamic array. So static array means the size of an array is static, and the dynamic array, the size of an array is dynamic. See, once an array is created, its size cannot be modified. So in our programs, when we declare an array, for example, I have a function void main, and inside this function, if I have declared an array integer of size a 5, then array of size of 5 will be created. So the question is where it is created. As it is mentioned inside the main function as a variable, just a vector variable, then the memory for this array will be created inside stack. So an array of size 5 will be created inside the main memory as a part of activation record of main function. So this array will be created inside stack. So why I am calling it as static? Because the size of this array was decided at compile time. Though the memory will be allocated during runtime only, memory cannot be allocated at compile time. So memory will be allocated during runtime, and the size of that memory was decided already at the compilation time. Definitely the size of an array has to be decided at compile time in C language. In C language, when you are mentioning the size of an array, it must be a constant value. It cannot be a variable. It must be a constant. So you must write some constant value there. But in C++, we can create an array of any size at runtime. So at runtime, a size of an array can be decided and it will be created inside the stack only. Whereas in C language, the size has to be decided at compile time only for the arrays inside the stack. Let us see in C++, suppose I have one variable n and C in n. So it means I am reading some input from the keyboard, the size of array as n. Then I can declare an array of some size n. So whatever the input comes from the keyboard, I can create an array of that particular size. So size of an array is decided at runtime. You can enter any value in n at runtime. So an array of that size will be created inside the stack. So size of an array can be decided at runtime in C++, but in C language it has to be mentioned at compile time only. This is the difference. And both these arrays are created inside the stack only. So there is no space to show you B also. So assume that B is also created inside the stack. So this part is in C language, and in C++ this is also allowed. Now next, we will learn how to create an array inside heap. So whose size and the type, everything is decided at runtime. Now one thing you remember, for accessing anything from heap, we must have a pointer. So first of all, I should declare a pointer. So I will declare the name of a pointer as a P. This is a pointer. Now where this P will get the memory? As A is a variable of type array, P is also a variable. So this will also get the memory inside stack. Now remember, in any language, when you declare a variable, the memory for that variable will go inside the stack only. Then when it will be allocated in heap, let us see. Now that pointer, I will use it for creating memory in heap. So then I should say P assign new int of size 5. Then the memory for 5 integers will be created inside heap, and this pointer P will be pointing onto that address. Suppose the beginning address of this contiguous memory is 500, assume that, then 500 will be stored in this pointer. So now the program can access that heap by coming onto the pointer and taking the address, and it can go there and access it. So heap memory cannot be accessed directly, it has to be accessed indirectly. Now one important thing I have to show you here, when you get the memory from heap, whenever you say new, then only you get the memory from heap. Otherwise, all the variables, whatever the variables you declare, they will get the memory inside the stack only. Now new is a operator that is in C++. Then how to create the same thing inside C? So for that, I have to say function malloc or malloc function, and I should mention the size. So I want 5 integers. So 5 into, now size of an integer, it may be 2 bytes or 4 bytes, depends on the system or the compiler. So I should mention here size of int. So this is the common practice that is done in C language. Instead of mentioning 2 bytes, we mention size of, so that depending on the system or compiler, it takes that size. Then malloc function will allocate just a raw memory, just the block of memory. Now that memory we want to use it as integer, so we have to typecast it as integer pointer. So this is in C language and this is in C++. New is the operator used in C++ and malloc function is used in C language. So once again, when you declare a normal array, then it will be created inside stack. When you want an array in heap, then you must have a pointer and then you should allocate the memory either using new operator or using malloc function. It will be created in heap, and the heap memory can be accessed indirectly with the help of pointer. Now one more important thing. When we have allocated the memory in heap and after some time during the execution of program, at any stage, if that memory is not required, then you must delete the memory also. If you don't delete the memory, unused memory, then it causes memory leak problem. If the unused memory is not released, then it causes memory leak problem. So how to release the memory? In C++, we have to say delete P. But P is used for an array, so it must be mentioned here as a subscript. And in C language, say free P. So this is the method of deallocation in C++, and this is the method of deallocation in C language. So I have shown you the syntax for both the languages. So the main concern here is how to get the array inside heap. Now next we will see how to access that array from heap. And this is a normal array inside the stack and this is an array inside heap. Now how we access this normal array inside the stack? So for accessing any location, I should say a of 0 assign 5. So the value 5 will be stored here. Now same thing I can say P of 0 assign 5. Just like a normal array, I can access this also. So the value 5 will be stored here. So it is as simple as accessing an array inside the stack. You can access an array from heap by using a pointer. So pointer acts as a name of a array. So already we have learned that this entire array can be accessed with the help of a loop, for loop. Then that array can also be accessed with the help of a loop. As we saw that this can be accessed using pointer arithmetic. So even that can be accessed using pointer arithmetic. So we don't have to relearn that thing. We already know it. Now the next important thing here is that wherever you create an array, whether you create it inside stack or you create it inside heap, once the array of some size is created, it cannot be resized. Its size cannot be changed. If at all you want to increase the size of an array, it is possible in another way, but it is possible only in heap. Stack array cannot be resized at all. But a heap array, same array cannot be resized, but we have some alternative for that. So let us learn how we can increase or decrease the size of an array.